In this assignment, you'll create a brick shooting game using the power cube and Samaflange assets. You'll learn about the rigid body and collider components, the instantiate, destroy and translate functions, as well as using prefabs. For more detail on these individual elements, see the lessons on them linked below. You'll need the Robot Lab asset package for this. See the link on this page if you don't already have it. To begin, open the empty scene, and then go to File, Save Scene As, to save it as our new scene. Save it into the Scenes folder of the project, and call it Brick Shooter. As we've used Save As, we are now inside the Brick Shooter scene. Let's start by making our wall of cubes. For this, we'll use the Power Cube. In the Models folder, you'll find various assets. So locate the asset called prop_power cube. It looks like this. Drag and drop it into the scene, and with your cursor over the scene view, press F to focus on it. To begin, we'll set up the lighting to work with this. Place this object on the Dynamic Objects layer at the top of the inspector, and in the mesh renderer for this object, check the box for Use Light Probes. Let's position this first brick in the wall at -3, 0.5, 0. Again, you can always reselect your object in the hierarchy, and with your mouse cursor over the scene, press F to refocus. Now that it's nicely lit, we'll add a collider and rigid body components to give it a physical mass. Using the Add Component button on the inspector, go to Physics, and Box Collider, and then Add Component again, Physics, Rigid Body. We'll be making many of these power cubes via duplication to form our wall, but we may want to go back and adjust properties for all of them, so we should turn this into a prefab now. Drag and drop this object into the Prefabs folder in the Project panel. This saves the object as a prefab, and we'll rename it to differentiate it from our model. We'll call it Physics_power cube, because it has the two crucial components, the collider and the rigid body, which mean that it's controlled by the physics engine. You should note that because this is now a prefab, its text is shown in blue in the hierarchy. Now let's make the duplicates of this to form our wall. Select the object in the hierarchy, and we'll use the hand tool briefly to zoom out. We can duplicate this by going to Edit, Duplicate, or by using Ctrl-D on PC or Command-D on Mac. Now we're going to position the bricks in our wall by using snapping. You can use snapping by holding down Command on Mac or Control on PC, and by dragging with the Translate tool. You can see that if I hold down the key and pull the handle, the object only moves in increments of 1. And because our object is modelled to a scale of 1, it will snap into that position perfectly. We'll then continue to repeat this step until we have 7 in our first row. Duplicate, Command drag or Control drag to snap. Duplicate, snap drag, duplicate, snap drag, duplicate, snap drag, and one more. This is our first row of cubes, and to organise them nicely, we're going to create an empty game object to store our row. So go to Game Object, Create Empty, hit Return on Mac or F2 PC to rename, and we'll call this Row. I'm going to position this in the middle of our row, so we'll place it at 0, 0.5, 0. Then to add our power cubes to this row, we will select them. So select the first one, hold down Shift and select the last, and then drag them onto the row in the hierarchy. Now they are all child objects of row. Now we can conveniently duplicate row and use snap drag in order to create the rest of the wall. So select row in the hierarchy and duplicate, snap drag up, duplicate, snap drag up, and continue this until we have 5 rows. Now that our wall is complete, let's work on our projectile. In the Models folder, find the Prop Samaflange asset and drag it into the scene. Let's drag it up so that we can see it, and hover and press F to focus. We'll set up the lighting by putting it on the Dynamic Objects layer and checking Use Light Probes in the Mesh renderer. We need this to be a physics object as well. So go to Add Component, Physics, Sphere Collider, and then Add Component, Physics, Rigid Body. Our projectile is now ready, but because we're going to use a script to create and launch this, we do not want it in the scene when it begins. So let's save this as a prefab as well. Drag it from the hierarchy and drop it into the Prefabs folder. Then we'll rename this physics_SummerFlange as well. You can now delete this from the scene by selecting it in the hierarchy and using Command Backspace on Mac or Delete on PC. Now let's set up our shooting. Begin by expanding the Cameras object in the hierarchy and select Camera 01. We'll reposition this camera at 0, 3, 10 and set the rotation to 0, 180, 0. So that now our camera, as you can see in the game view, is facing our wall of bricks. Because our camera will move around and shoot at the wall of bricks, we'll place the code for the shooting onto the camera. So let's go to Add Component, New Script, and we'll call this script Shooter. Double-click on the script icon in order to open it for editing. We do not need the start function for this, so we'll begin by removing that and also remove the comment above the update function. We'll begin with some public variables so that you can tweak settings or assign prefabs in the inspector. First, add a public rigid body variable called Projectile. We'll drag and drop our physics SummerFlange prefab onto this and use it in our Instantiate function in order to create instances of our projectile. Next, add a public transform variable called ShotPos. We'll create an empty game object to store the position to shoot projectiles from, and assign it to this variable later. Next, add a public float called ShotForce, and set it to 1000. We'll use this to define the amount of force to shoot with. And finally, add a public float called MoveSpeed, and set this to 10. This will define the movement speed of the camera to aim the shots. All of our operations must be immediate, so we'll perform them inside the update function. Start by adding two variables to represent the horizontal and vertical input axes. These are float variables called h and v. These are multiplied by time.deltaTime for smoothing, and then multiplied by MoveSpeed to increase the speed. We'll then use these values inside a translate command in order to move the camera around. So we'll say transform.translate and create a new vector3 with the values of h and v as components of this vector. So we'll be using the horizontal axis to move the x-axis of the object and the vertical axis to move the y-axis. To fire our projectile, we'll add an if statement that waits for the release of the Fire 1 button, which by default is the left-hand control key on the keyboard. Into this we'll add our Instantiate function to create the projectile instance, and then add a force to it. To begin, create a rigid body variable called shot, and set it equal to our Instantiate function. In this function, we need the object to create, the position, and the rotation as its three arguments. So we'll use our projectile variable, our ShotPos transforms position, and ShotPos's rotation. We finish the Instantiate line by adding as rigid body in order to cast the result of this to the rigid body type. This is because the standard Instantiate function returns an object, and we know the type of our instantiated object needs to be a rigid body. Finally, we use the rigid body variable shot to address that instance of our projectile stored in it and add a force to it. We do this in the forward direction of the ShotPos transform and multiply it by ShotForce. Now let's save this script and return to Unity. Reselect the camera and you'll see that our public variables can be seen on the script component. Let's start by assigning the physics SummerFlange from the Prefabs folder that we made earlier to the projectile field. Next, we need to add a transform to our scene to represent the position and direction with which to shoot. Create an empty game object by going to Game Object, Create Empty. We'll rename this Shot Pos, and then drag and drop it onto Camera 1 to parent it beneath it. Let's reset its transform so that it matches that of the camera. You can see if I zoom out now that the camera is positioned here, and if I select Shot Pos, click on the cog icon and choose Reset, then all of the values for the transform are reset to a default. And now if I choose the Translate tool, you can see that it's at the exact same position as the camera. But we need it to be slightly forward and slightly lower and tilted up in order to aim shots from below the camera in an arc pointed at the wall. So we'll set the position of Shot Pos to 0, minus 0.5, and 1 in the Z-axis. As you can see, this places it forward of the camera. Now we'll tilt it up by putting minus 15 into the X-axis. Now reselect the camera, as this is where our script component is, and drag and drop Shot Pos from the hierarchy and drop it onto the variable Shot Pos on the shooter script component. And that's it. Our script is now ready for use. Save your scene by going to File, Save Scene, and then press play to test out the game. Remember that the cursor keys, or W, A, S and D on the keyboard, are the defaults for horizontal and vertical, and that the left control key is Fire 1 to shoot. One thing we can do is to tidy up our stray projectiles. As we continue to shoot, we are adding rigid body objects to the scene, so we should really tidy these up because otherwise we are adding more and more for the physics engine to keep track of, which will eventually affect performance. Press play to ensure you are no longer in play mode, and then select the physics Samaflange in the Prefabs folder. Scroll to the bottom of the inspector and click Add Component. Then choose New Script and name this script Tidy. Double-click the icon to open it for editing. And for this, all we need is our start function. So we can remove the update function, and we'll also remove the comment. When this object enters the game, we simply need to use the destroy command, and we'll destroy the game object this is attached to, i.e. the ball itself. And because we don't want it to happen literally when the object enters the game, we'll use the second argument of the destroy command, which is the time delay, and we'll place in 5 seconds. We'll save our script and return to Unity. Now you should notice that when you playtest the game, once you have fired a few projectiles, they eventually remove themselves from the game after they've existed for 5 seconds. You can see that by watching the hierarchy, these objects are being removed from the scene, and they disappear from the scene and game view. So that's our brick shooter complete. Remember to save your scene, and try experimenting with different objects to fire, or different rates of fire, or different movement for the camera. And if you didn't understand any of the concepts in this assignment, check out the links to the lessons below.